about the cooling element. But this time round, we are trying to analyze the heat or temperature induced deformation of solid. Okay? So we have analyzed this before by using a rod. Okay? So let's revise what was the thermoelastic deformation in one rod. Imagine now you have a rod with initial length F. Okay? And then if you pull it, then you will have elongation. Okay? And if you now heat it, then you have the thermal expansion. So the total strain in the rod, which is the total length strain, can now be expressed as two parts. One is caused by the external force, that's the pulling force, and the other it was caused by the thermal expansion. Okay, so if you are not familiar with the strain, then you can write, you can go out in terms of the elongation. Okay, so you can see here, this is the rod. Okay, if you now doing the pull by external force, then the initial length will then have extra elongation. Okay, so this was caused by the support. And if you now do the heating, okay, if I do the heating, even without a pulling force, this will give me thermal induced elongation. If now I'm heating up the one which was being pulled, okay, then you have an extra elongation. So if now you add them up together, then your total elongation would then be equal to the one caused by the pulling force, and then the one caused by the thermal expansion. If you now divide them with the initial length, okay, then you will have the strain. This epsilon x is the total strain. Okay, it's caused by this external force. Okay, 因为我们现在应变的话，你可以这么写。So you can write this sum of the elongation is equal to the one caused by the pulling force and plus the thermal elongation. Okay, so this one can then be written as E A. Okay, this is the strain. Okay, and this is caused by the pulling force. Okay. 我们来看一下 If it's for simple rod, you can write this. This is basically F over A, and then divided by E. And then the other one is the thermally induced elongation. Then this is simply thermal expansion coefficient times temperature rise. Okay. 所以这个式子 ，OK， 可以看出这个一维的。So this is a 1D thermoelastic strain. One is caused by the external force, the other one is caused by the free thermal expansion. Okay? Okay, then next, okay, then we try to understand more about these 1D thermally induced elongations. So if the rod is cranked at one end but free at the other end, If you heat it up, then you will extend, the free end will extend, okay, by this L alpha delta T. This is what you learned before, thermally distribution. On the other hand, if both ends of the rod are being blocked, okay, meaning the free elongation caused by the thermal expansion is now restrained. Okay? So, how much is the force required to keep it there? So you see here, if the total strength is 0, okay? So meaning you need to induce certain force, okay? This term cannot be written as the block force divided by AE. If the left side is 0, okay, then I should induce a block force. Okay, and this is my AE negative alpha delta E. Okay, this is my AE alpha delta E. So means, you see, the block force is negative. Negative to the free elongation. Means the block force going to be opposite, okay, to your free elongation, so that you can free the free end to be blocked. Okay, it was previously a free end, but now it was blocked. It was restrained from extension. So then you have to apply the block force, and some load is negative for compression. Okay. 所以你在现在2分钟固定的情况底下，你在这个杆加热，原先这个杆可以做自由膨胀，它生产不会有任何应力。但是你现在2边都约束，它的自由生产可以约束，所以这表示说你的外界、你的边界要施加一个压缩力，这样这个原本会因为加热生产的杆，它现在就变得没有生产。Okay, now we're going to extend what we learned about 1D rod into 2D situation. So we learned about the 2D elastic situation. When you have a 2D plate subjected to stress in the x direction, it's going to cause the elongation in the x direction, but it's going to cause the contraction in the y direction. But if the same plate is subjected to vertical stress, it's going to extend in the vertical direction, but shorten in the horizontal direction. If you now consider the plate subjected to both the horizontal force and vertical force, then you have a combined force, which is 2D. Okay? So you have learned about that using 2D constitutivity equations. But now we're going to do one more step. After it was subjected to mechanical external forces, okay? If this 2D plane is heated up, what happened? Okay? So we assume that the thermal expansion is isotropic, meaning if you expand the same strength in the x and y direction, okay? If that's the case, then we're going to write a formulation later. Okay, so you see here. So step by step for 1D in the x direction and 1D in the y direction, then you combine them to be the 2D strength. Okay, in the 2D strength, the total strength in the x direction is caused by the horizontal force. is also caused by the vertical force. Okay, this is a component due to the Poisson ratio effect. Okay, and then next, when you heat it up, then you're going to have another thermal strength. Okay, then this is your final situation. Okay, and then now we're going to study how do you write the equation out. Okay, so previously you learned about writing the 2D plate, 2D membrane constitutive equations. So you have the strain summations in the x direction, you have strain summation in the y direction, and then you have the shear strain. Okay? So what's the difference between the elastic one and thermoelastic one? The only difference is the additional thermal strain added in the x direction strain and y direction. So thermal expansion will not cause a shearing. 因为我们现在看到的是说，你外力施加造成的形变，再加上热膨胀，差别在哪里？差别是在你的两个轴向的应变。首先你 x 方向的轴向应变，除了是因为这个 x y 方向的应力造成的，现在额外加了一个热应变项 ，OK？ 以此类推，你是 y 方向的这个应变，或者是因为这个 x y 方向的应力造成的，它现在还加了一个热应变项 ，OK？ 但是在剪切形变上，你加热并不会改变它的这个剪切应变。So now we start to apply our metrics again. How do you write the equation? Okay? So let's have a practice. Even when you go back, please rewrite the equation. Okay? To master this course, the only way to learn that is please rewrite everything. Okay? So you can write strength in the x direction is caused by the stress in the x direction minus Poisson ratio, and the stress in the y direction divided by Poisson ratio plus thermal strength. Likewise, in the y direction, you have strain contributed by the stress in the y direction and stress in the x direction plus thermal strength. And then the last term is then your shear strength. Okay. It's going to be written as the shear strength divided by G. G is equal to the Young modulus divided by 2 times 1 plus G. Okay? Now you want to write them in the matrix form. Before you're writing them in the matrix form, please get the method in order first. Okay? You have first the strain vector, and then the right hand side you have the stress vector. Then what you need to do is just filling up the matrices. Okay? So here, one more vector. Okay, that was caused by the strain, the thermally induced strain. Okay? 好，这个我们基本上要填倒是很容易。Okay, 唯一增加的是什么 ？So what's the difference? Difference of the non-2D element is this stress, this strain. Okay, let's write them in the red in color. Okay. So next, how am I going to re-express stress strain curve. Okay, you can see here the left hand side is the mechanically induced strain. In the right hand side, you have one thermally induced strain. Since they are straight, why not we shift it there? So then you have minus epsilon T minus epsilon T on the left hand side. All together. Now you can do the inverse. So the only thing that is difference is in the calculation of mechanical stress. Okay, you are using the difference of total strain and the thermally induced strain. So this is the mechanical stress. It's going to be your constitutive equations times the strain. But this strain must be pure mechanical strain. So then you have the total strain minus the thermally induced strain. 所以我们在计算机械应力的时候，所以你的这个式子呢，应该是你的这个杨氏模数乘上应变，但是这个应变呢，必须是机械应变，所以我们一般写的 epsilon x 是总应变，所以你要减掉热应变，你才会得到纯机械应变。Okay, that way, it's also for information. The thermally induced strain is this term, the one I marked in the red. So to express this hot, okay, is caused by the temperature rise. Yes, so that's the expression. Okay, now since you have realized that the mechanical strain is the total strain minus the thermally induced strain. The strain energy that we use to express in the derivations of systems matrix must be also expressed in terms of total mechanical strain. OK， 就我们这个式子我们要改一下，现在让大家看一下。So I have to highlight that there is no more pure expressions in terms of the mechanical strain. Okay. So then this one also. The button is red in color so that you realize. Okay, let's go through it step by step. First, the strain energy must be a mechanical strain energy, not the one caused by thermal expansion. Okay? So, strain energy can be expressed as the integration of local mechanical strain times local mechanical stress. Okay? So, this mechanical strain must be the total strain minus the thermally induced strain for x component, y component, but no difference in the shear component. Okay? 所以你在计算应变的时候，基本上你在计算应变能的时候，基本上很简单，1/2应变乘上应力。但是我们现在讲的应变一定是要机械应变，因为你在热膨胀的情况底下，你还有一个自由的热膨胀 ，OK， 所以不是机械应变。 你的机械应变一定是左应变减掉你热应变 ，OK， 在 x 方向，在 y 方向，但不在剪切方向，剪切方向不受这影响。And how to calculate how to express the strain? Okay, we're going to recall what we derived before. Okay, if you're not sure, then you write how you define the strain. Okay, remember, you write your u to be shape function n1 u1 plus n2 u2 plus n3 u3. Your v is n1 v1 plus n2 v2 plus n3 v3. Okay, this is for the triangular element u1 v1 u2 v2 and then u3 v3. Okay, so your strain in the x direction is del u del x. So then you're going to have del n1 del x u1 plus del n2 del x u2 plus del n3 del x u3. And then the maximum y is del v del y. Then del n1 del x v1 plus del n2 del x, sorry, this is del y, v2 plus del n3 del y v3. Okay, and then your shear strength is more complex. It's del u del y plus del v del x. Okay, so you can write the expressions in the same way. So now your strain, I will repeat it so that you know the meaning of B matrix. Okay? So previously that was the expression for strain in the algebraic way. But if you're writing it in the matrix form, it's going to be your n1 you're expressing it in u1 v1 u2 v2 u3 v3. OK， 好，同学看到没有？你学到这里，你现在要懂得很直观的做这样的一个方程式的转换，从一个线性方程式转换成一个矩阵的这样一个向量。So likewise, we are writing this. So it was very messy when you are writing in this expansion, but in the matrix form, then it's quite easy. And also, for writing the third component, you know that you are doing the swapping. Okay? So then you're going to write the n1, the y, the n1, the x. Okay? The n2, the y, the n2, the x, and then the n3, the y, the n3, the x. So what you're writing here is what you call a B matrix, which is 1 row, 2 row, 3 row, 3 by 6 times 6 by 1. And then this displacement factor, we sometimes give it the short form of delta. This is the displacement factor. This is the gradient of the shape function. Okay. be expressed as your D matrix times displacement vector. OK， 所以同学，虽然我现在是用解说的版本去给你写，但是你要知道它实际上的这个意涵。OK， 基本上你的现在的机械应变，如果我们这么写的话，写的这个意思是你的这个叫这个是 D matrix， 是这样的一个形状函数的斜率乘上位移向量，然后最后再减掉你的这个自动的这个热应变。Okay? So this is for your stress vector. If you now want to express for stress vector, then you're going to have your D matrix times this stress matrix. Okay? So this might have the duplication, then I remove it. This is the pure mechanical strain. Okay. Yeah, to avoid double deduction. Yeah. 这就是总的应变，还没有拿去算那个机械应变。So now you do the substitution of the expression in. Okay, you realize that. Let's mark the one caused by the thermal expansion. What's the difference? It is this term that is caused by the temperature rise. And likewise. Okay, so you can see now what's different between the normal strain energy for a cold solid and the one for the hot solid. Okay, after you do the substitution of the pure mechanical strain inside the definition of strain energy, okay, you're finally going to have the expressions here. Okay, so we can do the expansion so that you can see which term is there. Okay? Okay, let's first see the first term. This is the B delta minus mechanical stress times the stress, mechanical stress. Mechanical stress is the D matrix equivalent to your Young modulus times the B matrix times the displacement minus the strain energy. If you now do the expansions, then you see the part associated with the displacement vector remain the same, but now you have one additional term. Okay? The additional term is a normal displacement times B matrix times D matrix times the strength vector. Okay? The last term is not zero, but it's purely depending on the displacement. Okay? So this is not zero, so I should write them is independent Okay, you'll see in the next step. Okay, so later, okay, you can see that this is the first term is strain vector times stiffness matrix and strain. Sorry, this is displacement vector. Displacement vector times stiffness matrix times displacement vector. And then the next term is displacement vector times the force vector. 我们这一步直接把它推导开来。So let's derive it so that you have a better idea. 这个的话，这个是以前我们到 demonstrate, you are writing it that way. Okay. But now, in the presence of the thermal strength, your pure mechanical strength is going to be written as total strength minus the thermal strength times the stress. Okay? So your stress can be written as the constitutive equation times the thermal strength. Okay? So means if you do the expansion out, what will happen? If you do this expansion out, what will you have? You're going to epsilon transpose and D epsilon, and then minus this strength transpose, and then D E, and then what else? You have the epsilon transpose V minus ET, and then plus epsilon transpose V epsilon T. Okay, so in the presence of thermal strength, okay, your strain energy is now written as half this first term, the total strain one, second term, thermally strain, okay? Because they are scalar, okay? So you can written them as D, E, okay? Or you want to write the other way also can, okay? And then the last term will then be epsilon E, epsilon T, and then E. part。OK， 所以第一项我们来看，第一项就是你的。So what is the first term? The first term is half transpose, then is B transpose, and then B, and then B, and then B, and then B transpose. Okay? So what is this term? So if you recall, what is this? This is nothing but your so-called your stiffness matrix. If you take this up, absolute T,这一项就是你的技术过刚力学。OK， 还记得为什么可以这么写吗？因为过后你如果要找力的话。OK。这个就是你的这个 B 对。So this is the shorthand. But eventually, if you are solving the question, you are not going to write this shorthand. You are going to write the full. Okay, so I'll come back to the full expression later on. So 你看这些写的都是自己流出来的字，那后面的话，考试的时候你就是选这个全体证。OK， 不会说这个简历的选，我只是说用这个简历就告诉大家，哎，我后面这三项后面给你的是什么 ？OK， 然后当然做这三项也简单。So you now going to handle the last term. It's also simple. What's the last term? The last term is simply the thermally induced strain. If you are taking this and do the derivation with respect to displacement, any displacement, because it has no contribution of displacement. This thermally induced strain is previously assumed to be constant. Epsilon T is basically alpha delta T, and 0. Okay? So this is a 3 by 1. After transpose is 1 by 3. Times D matrix is 3 by 3. Times this epsilon T again. This is 3 by 1. It's going to be a scalar. It has no contribution with the displacement. After you do the differentiations, then this will give you 0. When I say 0, it's 0, 0, 0. Okay, after you have, yeah. Individual I, yes, 1, 0. Okay, but you have I, something like not 1, not 2, not 3, then you got 3, 0. Okay? And then next, the important term here. I might have some understanding. I try to get it. Okay? What about the second term? If I do the differentiation, let me express them in the epsilon term in front, B term at the back, and then epsilon T at the behind. Okay? So what is this expression? This expression is simply previously you have the expressions of displacement vector transpose, D matrix transpose, and D, and then epsilon T. Okay? D. I'm writing them in the shorthand. Yeah, you can still write them a vector. This one is a vector. Okay? So if you now try to differentiate it with respect to one of the displacement, okay, then this term is going to be 1, other term all 0, okay, transpose, and your VT D epsilon T dV， 这个都是这个矩阵，然后向量。这个原先是多少？原先我们算的是6乘3，然后转次过3乘6，是3乘6吗？6乘3。So what was it？ 3乘6。Okay， 6变成6乘3。然后现在 D matrix, what is the size of the D matrix? Is 3 by 3. And then the last one is the strain vector. Thermal strain vector is 3 by 1. So after you have done all this, you find out you have one term. And this is what you call the Norder thermally induced force vector. The size is 6 by 1. So meaning, if my previous knot was 1, 2, 3, okay, because of the thermal expansion, then I'm going to have extra forces, okay, caused by the, so your thermally force, okay, can be written there. 好，等一下我们来看一下这个例子长得怎么样。Okay, so this expression eventually will give you stiffness matrix and displacement vector, and then plus a force vector. Both are pre-multiplied by displacement vector transpose. Okay. So if you do the partial differentiation of the strain energy with respect to the Norder displacement, then you're going to have the stiffness component times this mechanical displacement vector minus the force. 看到没有？我现在的分析连外力都没有 ，OK？ 但是我拿硬电能对位移做微分的时候，我会出现2项。第一项是感觉像是这个热膨胀的时候，你的这个固体会有一个形变，这个形变的对应的应变的弹力，它是有在的，但是要减掉热产生的力，所以就是说它加融起来。它的这个外力为零，但它内部它有机械形变，再减掉一个热应力造成的力。Okay, so now we come to the actual working. Okay, previously it was all symbolic in the shorthand. Now let's express the thermally induced force in full. Okay. This thermally induced force is your D matrix transpose times your D matrix times epsilon t vector. Okay? So what is a B matrix transpose? Okay, according to our previous analysis, it is basically a shape function gradient. Okay? So your gradient, which was 3 by 6, after the transpose will become 6 by 3.所以它有6行，这行是打横还是列？行是竖的 ，OK， 这是6列3行 ，OK， 这是6列3行。然后这个 D matrix 呢，行列式到底是打横是行还是竖的是列？啊？对，行列式是一行2行，还是立行？立行，对，好。所以跟我们写的习惯不一样。如果在英文里面，我们现在是写 row， 然后再 column， 所以你们学的是列行式，不是行列式。OK， OK， 所以是列行 ，OK， 列行。Okay, so what we learned about this, we got now 6 row, 3 column for the B matrix, and then times the D matrix, which is 3 row, 3 column, and then times the displacement vector. This strength vector, thermodynamic strength vector is basically 3 by 1. Okay. 可能我们也来写一写，观众同学好像没有操作过的话，这个行业是中间有什么感觉啊？ So let's do the matrix to get the feel of how it's done. Okay? So your B matrix composed, and then the D matrix, and then your strength vector. The D matrix, we got y23, 0, x32, and then 0, x32, y23, and then you have your y31, 0, x13, and then your 0, x13, y31, and then your y12, 0, x21, and then 0, x21, and y12. So when you're writing this B matrix, okay, please know a pattern. The last one, first one is corresponding to the strength in the x direction. Second one is corresponding to the strength in the y direction. And then the third one is corresponding to the shear strength. So this term is basically the exchange, okay, in position. This one is exchange in the row position. This one is exchange in the row position. 所以你在写的时候，你自己要看一下，它有没有这个重复的这个 pattern. So there is a pattern of writing these straight equations. And then next you have this B matrix. Okay. So of course you can write 1B0, B10, and then 0, 0, 1 minus B over 2. The whole term multiplied by E over 1 minus B. Okay? 所以你如果要先做的话，你可以先把这个展开来。So if you want to do, then we can do the expansion. Okay? So let's write the expansion here, so that you have a hang on. Okay. So here in the exercise here, we first settle on this. Okay. 我们先一项一项。 let's first write the expression here. So you basically have alpha delta t, okay, plus, okay, let me make them a free row. This is okay. First row, and then first column, then you have alpha delta t, then plus b, and then times alpha delta t plus 0. This first row, first column. Now second row, first column. Then you basically have b times this. And then third one, then it's simply 0. Okay? So in short, what can it be written? In short, you can write this as one plus b times this displacement vector. Okay, so simplification will then have this becoming 1 minus b. Okay, you see that? So this is the first multiplication. So now we realize that, yeah, our term now has the last two expressions reduced to a displacement vector. 所以你现在是从这样的一个式子。Of course, not forget your area lah. That you are multiplying there. Okay. Do they have upper A? Like where's the A? So this is the term. Eventually we will have A, okay? Do we have A? Yes. 有面积吗？ Okay, let's have a quick check. 要不要随便记 So can one of you tell me? You need to multiply the area? 要从单位的角度啊，我左手边是力的单位是什么？牛顿。OK， 然后我右手边呢，这个是什么？杨氏模式是牛顿每米平方啊。OK， 左手边是牛顿，右手边也应该牛顿。OK， 所以这个 A 好像不大对哦。OK， 所以这个是可能单位长度哦。OK， 而不是单纯的 A。OK， 你的热力，因为你应该是变成牛顿每米平方再乘上牛顿。Okay, so let's go and check. Could it be A or not? Okay, this is per unit length. So I put it here. Okay, this is a force per unit length. Okay. So you don't multiply A, okay? So you see here, This one is your strain, okay? Yeah, we have this A part divided already. So let's check. This is alpha delta T. Okay, so again, this is force per unit length. Okay. So no area, this is force per unit length. Okay, after we have all this, then we do one more step. How do we do the expansion here? Okay, to do the expansion here, now you have one row, and then you have one column. Okay, let's do that inside the calculation. Okay, so let's put it aside. How do you do the calculation? So this is 3 rows, 6 rows, and then 6 by 1 column. So then you should have what's the vector? Your vector should have your 6 components. Okay? This is 1, 2, 3. Okay. To simplify my expression, I don't want to multiply too complex. I will just express this as this term. Okay? This multiplication becomes easy, isn't it? Then I should have this expression at the front, and this at the back. Then I have, this is now easy to calculate. This is row, column, second row, first column, third row, first column, and then this one, fourth row, first column, and then this one is the fifth row, first column, and then this one is the sixth row, first column. Okay, 然后你简化一下。Okay, is it matching with what you write? Yeah, you see here? It's matching. Okay. 最后我们就删掉，这里的塞过。Okay, now we come to the point. How do you apply to this? So you are asked to determine the equation for the plane stress element subjected to a temperature rise of 16 degrees. Okay, and then also the pressure acting perpendicular to the side. Okay, 所以形象上这个单元是什么？ Okay, what our derivation just now is you are telling people this BE and then the displacement vector minus thermally induced force vector. 这能告诉你的是。 外力为零的情况底下，然后加热，它相当于什么？它相当于 you're going to obtain an equivalent thermally induced tension so that your plane will expand. So this is the main point of obtain. Okay? So let's draw that out, because otherwise you may not be able to view that. This is basically 0. Okay? A 0 force vector. Okay? When you have the element, okay, heated up, okay, they are going to cause expansion. And this force vector is what we call the equivalent force vector is this. So do you see that? So even in the absence of external force, if you see a plane, okay, so if you're not sure what I'm talking, let's make the blade off. Yeah. So then they will expand to become this one. So it was previously cold, then heated up, then there will be equivalent tension to pull it apart. Okay, based on this expansion, will you be able to tell me what are the sign of the tension force? Okay， 这个数字已经很复杂了，我们能判断的变成很有限。来，我们现在来问一下同学，正负号 ，OK？What is F1x？ 来，同一个同学，正的负的。看图哦，注意正的还是负的？它加热膨胀，我左手边加热膨胀是什么？我右手边加热膨胀是什么？ So what's the sign of the force direction? I define x to be positive towards right. But now because of the thermal expansion, it's going to expand up. So on the left hand, the thermally induced force will be 这个还是负的 ，OK 好。然后下一个我们问这位同学 ，F2x 是正的还是负的？
正的。
OK 好。F3x 正的还是负的？正的。OK 好，我们再歪一下。来 ，F1y 正的。我看是什么？负的。它是在原先的线之下，所以是负的。OK, F2y, what's the sign of the? 来，各位同学 ，F2y 正的还是负的？负的。OK, 因为它是往线。OK, next, how about the F3y? 来，各位同学。啊 ？OK, 看到没有？所以你们自己解题的时候啊，数值不见得对。 但是正负号一定要对 ，OK， 当然数字也对，那是更好。So you should have basic way of checking is your sign convention correct? Because this thermal expansion is caused by the expansion force, the tensile force. Okay. So next, we're going to calculate the equivalent force for these triangle elements. But to make the thing complicated is, other than free thermal expansion, I now have one side subjected to pressure, okay, equal pressure. Okay, so this plate has a thickness T, it has a modulus E, and it has a thermal expansion coefficient 12.5 times 10 to the power of -6 per degree Celsius. And then my Poisson ratio for the material is 0.25. Okay? When this plate has their side 1, 2, 3, 2, 3 subjected to tension, and then some more, the whole plate is being heated up. Would you be able to calculate what is the normal forces? Okay, determine the equation of free stress element. Okay, so you have now two loading. First, we can write the stiffness equation. Okay, you have the B matrix is equal to this expression divided by 2A. Okay, this is the shape function gradient. Okay. So yeah. So you can be expressed as this coefficient. And then next, how much is the area? Right. The northern coordinate 1, coordinate 1, 1, coordinate 2, and 1, coordinate 3. And take the determinant. Then you find out this area. And then substitute the value into the expression, then you're going to have your B matrix, and then next formulate your D matrix. Your D matrix can be obtained this way, and then finally, then you're going to have the B transpose D. Okay, and then last, 3 multiplied by B again, then you have your K matrix. Okay. So until this step, please get prepared. You first have to do hand calculations. And then next step, for second half of the final examinations, we might get you to use MATLAB to do the symbolic calculation or numerical calculation because it's more complex. Okay. 那么之后要练习用 MATLAB 去做这个矩阵计算，因为手算已经非常困难了 ，OK， 要算得对，这个3×3以上的矩阵，这已经有点挑战了。现在我们是6×6 ，OK。 obtain the equivalent thermal induced force. Okay, it's easy to write the thermally induced strength. It's 3/1 vector. But thermally induced force is 6/1 vector. It's obtained by B transpose times D times the thermally induced strength vector. So the calculation itself is tedious, okay? Even though doable, eventually you can find this force vector. 来，我们来看一下，虽然我们不知道这个数值对不对，但我们先来看看它的正负号。So let's check. If this is being heated up and expand, and we also now add the note number. Okay, so let's check the sign. If it is correct, 我们看一下这个力的向量，就是 U D U 2 D 2 D 3 D 3，我们就看 UE。Okay, so now we check the force direction and the expansion. You see, the not one horizontal displacement is negative. Okay. Not two horizontal displacement is positive. Not three. Okay. Horizontal displacement in this case surprisingly is 0, meaning it remains the same neutral line because this is a symmetry structure. 这是等边三角形，所以在节点3，它水平位移为0。OK， 如果受热的话 ，so this will be reflected in the 0 thermally induced tension. Okay, and then next we check the vertical displacement. Vertical displacement for node 1 is coming down. This is negative. Okay? And the vertical displacement for node 2 is going down. So this is negative. And then the vertical displacement of the node 3 is going up. So this is positive. So now after you do the calculation, you can have a quick check whether you have the right calculation, at least for the sign convention. Okay? So this is how you. Okay. So if you are not sure, then we have to draw the sign. Okay? 你这个从这样的话看。 trouble you is how do I calculate the pressure？ 所以最简单的方式是怎么算？反正这个压力是平均分布的，所以这根面的总力是多少？就是你的压力乘上斜面积嘛 ，OK？ 然后你刚好用平均，你就把那个斜面积的力2等分，然后这个力又因为是跟斜面的关系，所以你自然要把这个力又再投射到 x 方向跟 y 方向。How to calculate the force caused by the uniform pressure? It's very simple. Pressure times the side area, then you got the force. This force is directed perpendicular to the line. So in order to reduce it into the horizontal and vertical component, then you're going to have that inclined force times cosine the angle, then you have the horizontal force, and then times sine, then you've got the vertical force. And now you want to divide the force into 2 knots, then you take the horizontal force divided by 2 to be acting on each knot, and then vertical force divided by 2 to be acting on each knot. So in that way, eventually you're going to have the normal force. But will you get the same by using the shape function? Yes, you can. So we're going to show you a tedious way, but it will lead to the same finding as our common sense do. 我们这个做法虽然是有点复杂，但是它会跟我们刚才等分那个力的做法是一样的。首先我们先算出斜面的长度，然后再把你的这个压力，因为压力一定是跟你的边成垂直，然后你要把这个压力根据边的角度，把它压力分成就是分量跟垂直分量 ，OK， 然后再去做这个复杂的动作。So you're going to get the normal force. Okay, because you're not going to teach your computer how to apply the common sense, how to divide equally. This is impossible to computer. Okay, and some more you are talking about a vector. So in order to teach computer how to do that, you're going to introduce a shape function matrix, pressure, and then in the x and y direction, and then integrate along the line. Okay? And so this integration along the line and the shape function, 所以这个形状函数是有点复杂的，我们来画一下。So you have 1, 2, 3. Okay? This one is more complex. This is good. 1, 2, 3. You have the pressure to be normal. You have to reduce them in the x direction and y direction. So your px, py can be written as p times cosine theta and sine theta. Okay? So this is your angle. Okay? So how you obtain this angle? You obtain this angle from your side angle. Okay? So this is then theta. Okay? This is 90 minus theta. And then this one. Yeah. This is also 90 minus theta. Yeah. And then this is 90 minus theta. Then finally you find this is the theta. Okay? So you now express this. And then next, what's the work done? According to our previous calculation, the work done by the force must be Fx times Ux plus Fy times Uy. Okay? So what is my Fx? My Fx is Px times Ds. Okay? Times Ux. Py times Ds times Uy. Okay? But my Ux and Uy are a function. done by the pressure. Px, ds, ux. Py, ds, uy. But my ux is equal to n1 u1 plus n2 u2 plus n3 u3. So my force F1 is then equal to del W del U1. Okay? So this will then be Px, ds, and 1. My force 2x is del W del U2 Px, ds, and 2 by differentiating with respect to U2. F3x equal to del W del U3 then Px, ds, and 3. So you can do the same for your these vertical forces. So by doing this, then you have n1 px. This is the f1x. Okay? You have n1 py. That is f1y. And then next you have the f2x, f2y, f3x, f3y。就看到没有？通过这个方式，我就把这个节点的力都找出来了。我们会很习惯的用这个微分的方式来写，但是对 Method 或者是对电脑而言，没办法，你就是非得把它转换成矩阵，然后做矩阵相乘除。虽然你手写那个写法比较快，但是对电脑而言，你就非得把它写成这个是6乘2的矩阵乘上2乘1的向量。Okay, so in that way, after you do all these, then you finally have the expression. So in short, now you have the elastic force in balance with pressure-induced force and the thermally induced force. Okay? So now you can find out how much is your displacement. Here displacement must be an accumulation of all strain, elastic strain and thermally induced strain. So that's the total displacement. So in that way, you finally do the solved solution. Okay? So, okay, I think then we'll stop here and break for 10 minutes. We'll come back to tell you a formulation of another way of deriving triangular element. 好，我们现在休息10分钟，回来再跟大家介绍怎样用这个其他方法去找出同样的元素。OK， 谢谢。